I'm going to show you what it takes to make a 3,000 horsepower Viper. Alright, so first thing we're doing is we're going to be driving the sleeves out of black. I'm not going to show you that because that's just me and my guys beating the sleeves out with a hammer and a fixture that I made to drive the stock sleeves out. So this is a just a stock block. We're doing 3 of these at the same time right now, and so we knock the sleeves out of it. We have to do welding on the block. We have to do a 55mm cam tunnel because I do a 55mm roller bearing in these. And then we install caps. So we make our own caps. We do we do the cam tunnel here. Not on the great big new machine yet because it's still not up and running yet. So you'll see us do that on the Centroid. And then you're going to see us do all the machine work. And we're even making our own sleeves. Well, we're having our own sleeves made for us. And it's not by anybody, actually, that you know. We're actually having to do that because sleeves is such a problem to do. So let's go over and look at these sleeves real quick and I'll show you that. Alright, so this is one of our sleeves. Now what we've done is we're buying blank sleeves. So I guess I have to correct that. We're not making the sleeves here. We're actually buying a blank sleeve. So this sleeve is, I think it was 9 inches long to start with. And I'm really only hunting for the ID and allowing the OD to be bigger so we can have it all machined down. So our buddies over at Accelerated Tooling, i.e. Torque Storm, they have all sorts of CNC lathes, so they cut all these things for us. So you can see here, it's a 2-step sleeve. So this portion here is machined and pressed into the block, similar to what the stock one is, but thicker. Okay. Then we have this large barrel portion here, which provides all the strength for massive cylinder pressures. Then up here we have our second step, which also has flats on it. So a flat there, so the sleeves meet up together in the middle and leaves this large sealing ring up here that we put the receiver groove in for our stainless steel SMX hoops. Alright, so pretty cool stuff here. So we'll go right through the process and show you a little bit of the cam tunnel, the little bit of making the caps, welding the block, and then machining the block and what the block looks like after you machine it and before you machine it. So what we do here is we put this up in the Centroid because it has 50 inches of Z travel on it. Is it 50 inches of Z travel? Yep. And this is the roller bearing that we put in it for 55mm all the way through all the bearings. Because Vipers have a weird deal where there's no cam bearing in the front and it's big and then it goes smaller. It's kind of screwed up. So we're putting in these roller bearings and doing that. We've indicated, or Brock has indicated in the block off of the main saddles right through here. Indicated the whole thing in. Then we'll give this a little machine haircut up here to flip it over, make it even easier. And then we bore these first 3 cam tunnels, flip it upside down and bore the next 3 cam tunnels. Then we put it in the line hone and final line hone them to size. What we're doing here is we're working on the line hone now. So we have bored the cam tunnel in the big Centroid machine. So we bored it in the Centroid, but you can't do a single pass. This is the whole problem with things is you have to go one half of it, flip the block over, do the other half of it. So there's always a possibility of having a slight misalignment. So we leave a little bit of material in there so we can line hone it and make it straight. And it's actually pretty darn good. It's probably as close as I could figure. It's probably only about 0.5 thousandths off, or was about 0.5 thousandths off end to end. So now we're honing and checking size. So Cody, you want to go ahead and start checking size on there? All right, now here we got the sleeves out of the block. So this is what what it looks like a stock block looks like with no sleeves on it. Now the stock block does have a slight step up here, all right, and then straight down. So they seal up. It's a dry sleeve, which means there's no water anywhere around the sleeve, all right. And step means it has a step right here where it's bigger, where it sits down and can't be pushed down any farther. Now on this block, we already have our main caps on, so you can see how we make the main caps and how quick we can make it. That is it. Bing to bing, 3.5 minutes. That's crazy cool. This is the final product. So what we do here is we throw this up in the old Rottler F69 after we make the main caps in the Haas VF4. So we throw it up in the machine, and sorry I probably didn't video that part of it, but this is what the main caps look like on here. So when it goes up into the Rottler, this main cap is just slightly smaller than the block. We come in here, the Rottler bores it, does the line bore. Then we, after that's done, then we just run it through the line hone just to do the finish sizing. So this is our billet aluminum main cap. Now there is some billet steel caps. I prefer the aluminum caps because all the material is all the same. Strength wise, if a top fuel car uses an aluminum cap, okay. So anyways, we have this all done, and now we're going to go through and to dry deck this. Let me flip this back up here. Part of what we're doing also is we're dry decking this. So that's why we do the welding on these water passages. So this is a water passage, water passage, water passage, water, 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 water. The only head bolt holes are just these four right here. So we increase these head bolts to 1/2 inch diameter. We weld up all these holes here. We remachine everything and install our custom made sleeves, which end up being a wet sleeve. We'll show you all that stuff here, but we'll just go through and show you a little bit of welding, how this thing all looks, and what you need to how this works. Woo. I have been officially authorized to hit the green button. How about that? So here is, we've bored this bottom section. So this whole section down here, right here, This is all, I think, how much did we bore that right there? The very first cut? Can't remember.
Yeah, it was just a skin cut, 10-15 thou.
Yeah, pretty much this is a pretty close. It's a little bit larger. Don't remember the exact number off the top of my head, but a little bit larger down here than what the stock bore was, the stock sleeve bore. Okay, and then we machine for this entire step, so we have all this meat right here in a very thick cylinder wall cast iron, because that is a problem. There is very thin. You can see that there's material here, no material. That's like absolutely nothing right through there. So this will go down, and can't really put it in here yet because we're not all the way out the sizes, the final size stuff, and it would be getting pressed in. So now we're going to cut this flange dimension right here in the very top. And it's going to cut all of this out. There will be nothing here, because this sleeve will butt right up with... You want to grab the other sleeve? These sleeves will be just exactly like that. This edge is round, doesn't have a flat because it's on the end. And we still allow a very minimal amount of water to still go through in between the sleeves. So it's still going to be able to cool really well, and still have this really thick 250 thousandths plus thick sleeve material right here. So it's going to be really nice. Here we go. Now this is, you can see all this stuff was all welded up. There used to be a water hole here, used to be a water hole here, water holes here, etc. So now we're dynoing over in another dyno room. You can hit it, I don't need to touch it. We'll see it. So it comes around and finds its zeros, and then it does it stops here and then rolls up this position, because then it always wants to take any backlash out of the fourth axis. Back up so we don't hit anything in their eyes. Alright, there you go. This is the way it normally runs. We just had that up so that you can see easier. Now this is the multiple steps right through here. But what we've done is, when we get this all done right through here, and we'll show you this whole process of this portion of it, you'll see that there's no water anywhere on the deck surface whatsoever. Alright, so you saw it cutting the counterboards up here for the flange right there. So this outside flange, or the top flange maybe you call it, the flat flange, I don't know. But anyways, you can look right down in here. You see how they fit together like that. Cody's got them fit in there really nice and tight, and has cleaned out all the existing old material. Just roll it over to show that the other. Now this is all welded up right through here, and this little area right here, we're just going to be sealing that up, and it's pretty darn tight, but we'll be sealing this up just with sealer as we're putting it all together to make sure it doesn't leak up through this top area. Not a big deal, but there's water all up in this area anyway, so there's a little area where we have to seal up. It wouldn't be critical because it would just be a seep, and it would have a copper gasket on it anyways, and it probably would never leak or do anything. But we will just seal this up and put sealer on because I want it to be like perfectly dry if possible. Go ahead and roll it over, and you can see the back side. You can see the back side of this thing, of what it looks like beforehand. So we kind of pick this all the way and get it out of there so it doesn't obviously screw anything all up when we're putting the sleeves in. So we're going to put the sleeves in this. I think we'll probably freeze them. So we'll put the sleeves in this, seal them all up, and then the next thing is we'll do the receiver grooves in it. Then we'll bore it to size. We'll make sure everything should be set exact, so they should go down the exact amount. We really shouldn't have to deck. So you're going to leave the sleeve proud or protruding. So proud, imagine my finger is the deck surface, or my fingernail. Instead of being perfectly flat, it's proud or protruding. We're going to leave that 3 thousandths or so up, 2 to 3 thousandths up. So the copper head gasket comes in and squishes into it. It actually kind of forms around it. It actually is kind of like a secondary seal, to tell you the truth. And also helps to force the sleeve down and keep it down even more. So you can, in a used engine, very common, if somebody's resurfaced the block with the sleeves in it, then it's all flat and the sleeves are not proud. They don't stick up any. Most of the time, that's not a real big deal, but in a brand new application, and if possible, I would always like to have them stick up proud. That makes it, I think it makes a better sealing for it like that. So, Cody's going to finish cleaning up all this mess of super thin material here, and then and it's interesting where there is material on this and where there's not. And it's kind of neat. You can see the gaskets. You want to roll it back over?
Back over.
Yeah. You can kind of see in there. It's a better picture, so you can get an idea of how the water flows around here, the head bolt holes, etc. Oh, and we have to drill and tap for 1/2-inch head studs. So we'll be working through all of this. We'll show you all that, and we're going to show you each little piece, and then show you a finished block of what this thing all looks like.
Liquid. I'm pretty sure we didn't use his engine stand for anything. Hell block has even been values here. Like the block is so big, it didn't fit. Yeah. Going to jail. Let's get that out. Well, what if they do?
Tap the side.
See, it's just rocking there. It goes. Once it gets past that upper lip, it goes right in. My corner. What are we gonna do? It looks perfect from up here. This side. Too far. Yeah,
Now here we are with the finished block. You can see everything is all super nice here. Notice just head bolt holes. These are all plugs, so that's where we welded everything in. And in between, and then you can see these large diameter interlocking sleeves. Very nice. I'm super happy with the way this new setup is all working out, because we still have a very minimal amount of water that will come in between the sleeves, which is great. We're not trying to do anything stupid with bringing water up through around the sleeve and up through gasket. This is all dry decked. So there is no water, no water, no water, no water, no water. And this particular application though, right at the end of the head here, so there is one spot by head bolt holes here, pretty darn close. That one's, you know, there's so much material here. Receiver groove for the hoop cylinder heads. Here's the hoop cylinder heads right here. So these, you can see the hoops that are in the cylinder head. The head is all dry decked. And these are all, everything is plugged through here because they're all round plugs on the cylinder head. On the block, we have to weld them. But what I'm doing right here is I'm allowing this to, they can do it one of two ways. We can plug these holes right here, plug them in the head, and then tap and plug these, and they can run an exterior line from the back of the block up to the cylinder head right here, which is a little hard to fit sometimes, or because these two holes are so close to the head studs that I feel that we can use, and these two holes here, which would feed water up to the back of the head and then all the way through to the front, and then exiting out the front of the stock port location right here. So is there a slight chance that you know, you could blow it right here? Possible, but it being so close right here to the head studs, not all that probable. They typically blow right here, and you know, here or there, or in between the cylinders. Very rare that they blow out right at that particular location or in the front location. And when we put them close to the head, it gives a lot of clamping load area right there. So you can see, I'm pretty excited, pretty happy. The sleeves protrude 3 to 5 thousandths of protrusion. The sleeve actually sits down in that bottom step like I showed you earlier with the multiple steps in it. Super thick material right here of ductile iron sleeve. Very cool deal. So this is your finished project right here on these sleeves and that whole setup. Fire hoop, sleeved, but still wet, dry decked. Very awesome. Anyways, I'm Steve Morris. Like, subscribe, look at new merch that we got going on, any of those kind of things, and have a great day.